Hello, 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 hello. Check, 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 check. Huh. So this is the OpenGL Android water animation session. I was trying to go live early in the morning, but the same issues that were yesterday persisted. So I got my internet corrected. Hopefully, we can have a continuous stream today. Hopefully, I'm able to stream till 5, as in a 3 hour stream. I had done try to stream live in the morning, but that first stream got entered like some 29-30 seconds. After which, what I thought was I would do a local recording and upload it. And that I did for 1.5 hours, I guess, but I may not be uploading it. Nothing significant happened in that. So, to give a quick walkthrough of what happened in that session, um, yesterday when we were here, as in when we were, if you see the screen, um, we we had read the article I will again link in the description today. And in that article, there were two types of textures involved and a frame buffer involved. So the questions that I had come up with is what is the type of textures, as in what is the data type of the textures. I'll just put data type as well. Then how is frame buffer object initialized? Frame buffer object is something that was being used extensively in that particular article. And how is frame buffer object added to OpenGL pipeline? How is a screen state saved? These were the questions that arose after I read the article. Then I came up with some sort of algo, which I think is how things are working, which is I associate a texture to front texture. I use this to calculate the frame buffer object. Then the frame buffer object is used to render on screen. Then I swap front texture and back texture and do the process again. Now, creation of texture. This is something that often I get confused. What is a difference between an image and texture? Because in the end, image only gets transferred to texture, right? So if you see the scene, uh, if you see the scene, the texture is basically what you initially. So in this code, you can see that you initially actually have a int array, and the int array is having a text is called the texture handle. Then we do a gen texture handle to the int array. I think here is when the some sort of value is assigned to the texture handle, after which we do create a bitmap from the resource that we had. We create a bitmap from the image that we had, and then we bind the texture handle to the texture 2D. We make sure that the texture 2D min filter and max filter are set, and then we create the GL utils text image 2D, right? As in, we feed the bitmap to the saying that this is the bitmap for the texture 2D, right? And this is and then we recycle the bitmap and we return the handle. So basically, a texture is a number, and we associate many things to the texture 2D, right? GL texture 2D, bind texture 2D, and all that. Yeah. Okay. Now, what we can check is GL bind texture, right? GL bind texture GLES20 GL texture 2D, right? Which should mean that um, uh, GL texture 2D should be the texture that is going to be shown on the screen, right? So, is there a way of binding texture to some other frame buffer, right? Let us try exploring that part. Uh, yeah, but apart from that, so that is what a texture is. Now I'll just maybe first I'll just complete what was there in the initial morning session. Um, where was I? Yeah, here. So okay. Then after which I think this is the algorithm for water droplets moving down. This we had explored yesterday as well. If current water state is water or empty, if state above is water, current state is water. This is the starting point of the algorithm for water droplet moving down. This doesn't take into account collision and all that. Then we went through a frame buffer object article. So this I will show here. Uh, where is this frame? Yeah, this is the one. In this frame buffer article, it is written that frame buffer objects are OpenGL objects which allow the creation of user-defined frame buffers. Right? This is user-defined frame buffers, and with them, one can render to non-default frame buffer location and this render without disturbing the main screen. So we can assume that there is an OpenGL frame buffer and there is a user-defined frame buffer. And this is the difference between the default and non-default frame buffer, right? So you can even when they concur on this, the default frame buffer is the frame buffer that OpenGL is created with. It is created along with the OpenGL context. Like frame buffer objects, the default frame buffer is a series of images. Unlike frame buffer objects, one of these images usually represent what you actually see on the on some part of your screen. Okay. Okay, this is what we went through first. Then after which, each frame buffer is associated with multiple objects. Image, layered image, texture, render buffer, attachment point, frame buffer, attachable image, and a frame buffer, attachable layered image. So these things are associated with the these things are associated with the frame buffer object, and yeah, yeah, so apparently it is not a very evident how these things differ from one another. The one image and texture difference that we were noticing earlier, right? Texture is having a number associated with it. Texture is having a bitmap associated with it, right? And texture is having a bind also associated with it. And we were trying, so this part was what we explored, and after which we were trying to understand a pseudo implementation of the frame buffers, which we'll look into after some point of time. Now if we move on with the whatever is written here, yeah, so we can see that this is the same things, the six or seven things that were written in that particular article. So this is my kind of understanding. I would create this is after going through the JS code that was there in the article. I would first create the frame buffer object offline, load the image as the initial texture point input, store the texture in the said frame buffer object. After frame buffer is processed, move the frame buffer object into the main screen. So basically, we create a texture uh, and we move it to, and we attach a texture to a frame buffer object, and then we actually do some sort of processing on the frame buffer object. And when you get a response, you then you then store that response, right? And then you make sure that this particular frame buffer object, a frame buffer is then loaded into the main screen, and the response frame buffer object is used as input for the next rendering of this particular screen, right? So this is my kind of understanding as of now, at least. Now we will try and understand what is a bind texture doing, right? What is GL bind texture doing? Let me first go to the stream and check whether the sound is loud or all those things, right? Whether I am live, whether sound is there and all that. Let me first go to the stream and check whether the sound is loud or all those things, right? Oh man, whether I am live, whether sound is there and all that. Let me first go to the stream and check whether the sound is loud or I will show here. Uh, that um, min filter and max filter are set, and then we create the GL utils text image studio, right? As in, we feed the bitmap to the. I think I have to end this stream. I think I can start as a second stream because my video quality I actually changed for recording locally, I guess. But now this actually persists, and I don't think I'm able to read stuff that is done in, especially the Android Studio changes, right? I don't think I'm able to read that. So I think I'll just end the stream and start again, and then this time I will make sure that the um, output quality is better. Yeah, I think ciao ciao. I'll just do this. End this particular live stream and then again start again with the correct video setting. Okay, then I'm ending this. I'll start again in maybe like 2-3 minutes.